Hi everyone, my name is Qin. In this video, I will teach masks RCN, a model for instance segmentation. The main idea is simple. Faster RCN already predicts a class label and a bound box for each object. Mask RCN adds one more output, which is a pixel mask for each detected instance. By the end, I want you to understand what problem mask RCN solves, how its pipeline is organized, why ROL align matters, and what a mask branch actually predicts. And this video is initially focused. I'm assuming that you already know CN features, maps, and the general RCN families, especially faster RCN and its region proposal network. So I will not spend most of the time teaching Andrew's box regression or non-maximize suppression. Instead, I will focus on what changes when the output has been not just a rectangle, but a pixel accurate mask for each object instance. The four goals are understand the task, understand the architecture, understand ROL align, and understand how the mask headed is trained and used. Here is a problem hierarchy. Imagine classification. Answer one question. What is the image? Object detection as location, usually by predicting bounding boxes and class labels. Segmentation is pixel level, so it assigns a class label for every pixel. But segmentation normally does not separate different objects of the same class. If two cats touch each other, they may both just become cat pixels. Instead, segmentation combines detection and segmentation for every object instance. The model predicts a class, a bounding box, and a spread uh, mask. This is the task mask RCN was designed for. And mask RCN sits naturally after the RCN family. RCN introduced region-based recognition. Fast RCN made the method more efficiently by sharing convolutional feature. Faster RCN learned the proposal step with a region proposal network. Mask RCN keeps this two-stage detector structure. The important additions are ROL row align and mask prediction branch. This is why I will reference faster RCN, but the main focus is the segmentation part rather than the enter detector pipeline. The pipeline can be read from left to right. First, the input image goes through a convolutional backbone, often with a feature primed network to handle multiple scales. RPN process candidate object regions for each proposal. Row align extracts a fixed size aligned feature map. Then the second stage has parallel hands. The class had predicted the object category. The box had refines the uh, bounding box, and the mask had predicts the pixel mask. The output for each detected instance is Therefore, a class label, confidence score, a box, and a mask. The first stage has the same conceptual rule as the first as the RPN asks, where are likely objects? It processes candidates box that should cover objects with high recall. This is important because the mask RCN is instance first. It first isolate candidates object regions and then predict a mask inside each region. A limitation follows directly from the design. If the RPN fails to propose or a region that covers an object, the mask branch cannot recover that object later. The mask need only works on proposed regions. Row align is one of the key technical details. Earlier, faster and faster are CN system with row poll. Row poll convert a proposal into a fixed size featured map, but it does this with coordinate quantizations. It around the region boundaries and bin locations for classification. A smart shift may not matter much, but for mask prediction, the output has to line up with the object pixel. A one pixel shift can damage a boundary. Row line removes that harsh rounding. It keeps the floating point coordinate and samples feature value using linear interpolation. The result is a fixed size row feature map with better pixel-to-pixel alignment. Uh, the mask branch is a fully convolutional network applied to each aligned row feature map. Its output is a small spectral grid, such as 28 by 28, that represents the object mask inside the region. The class and the box hence can summarize that what the object is and where the box should be. But the mask head must preserve a special layout. During training, the target is a boundary mask for the ground truth class inside that row. In other words, the branch learns which pixel inside the coordinate region belongs to the object and which do not. Mask RCN uses multiple tasks loss. It keeps the classification loss and the bounding box regression loss from a first RCN and as a mask loss. The mask loss is usually binary because intro of the mask target for the correct class. This let the mask branch focus on the foreign ground versus background pixel inside the region. In inference time, the model keeps high confidence detections apply the filter ring, such as non-maximum suppression. Select the mask corresponding to the predict class and resize that mask back into the bounding box position in the original image. A useful conceptual check is that the class and the mask are predicted in parallel. The mask branch does not need to detect the category by itself. This example shows the kind of the output we want. The image has two cat and a chair segmentation mode A model might label both cat as cat pixel, but may not separate the individual cats. Mask RCN is designed to produce a spread mask. Cat instance 1 and cat instance 2. The bounding box gives a round uh, rectangular location, while the mask gives a shape. This makes output useful for tasks such as counting objects, measuring area, and reasoning about overlapping objects. The strength of the mask RCN comes from combining detection and segmentation. It separates object instance handles overlap rather than segmentation along and return outputs that are easy to inspect, Flashbox and mask. But the nation is not perfect. It depends on region personas. So Mr. Proposals means Mr. Masks. The structures crowded sense and heavy calculation can still be difficult. Also, the piece size row must be resized in the final box. So very small details may not serve as helps explain why larger segmentation system explore different designs. To summarize, the MR mask RCN is a model for instance segmentation. And its output is a class label or bounding box and a separate pixel mask for each detected object instance. Architecturally, it is easily to remember as faster RCN plus two key changes, row, line, and parallel mask or prediction head. The reason this changes work is that the segmentation needs a spatial alignment. Row align preserve the coherence between the region and the features on the fully convolutional mask head predicts a spatial mask. Thank you.